Uh, Let everybody join in. Let us see.
Good afternoon, sir.
Good afternoon. Okay, we will start now. Um, Good evening, everyone.
Good evening, sir.
Good evening, sir.
Good
Uh,
evening, sir.
Good evening. Good evening, Sushma ma'am. Okay,
Good evening.
okay. Now, I would like to revise today. How many people, in fact, class 10 had not attended last, I think, two sessions. So, what would they like to know? We'll start with them.
So mainly, can you explain about the capacitors?
Capacitors. Okay, capacitors. All right. Capacitors. Fine.
Sir, I missed the class where you explained about the breadboard.
Yes. Breadboard. True. We do breadboard also. Okay. Guys, first and foremost, if I give you an assignment, the assignment has to finish on time and I need to have the assignments from all of you. Okay, so there are 40 plus people in this group. So I need to have 40 plus assignments with me, not 16. Okay, so I need to have from everybody, from everybody. Okay, all right. Um, what I'll do is I'll just put some things on screen so that while I'm explaining, so we can talk about them. So let me share the screen. All right. Can you see the screen?
Yes, sir. Yes, sir.
Okay. First of all, do we know about electricity? What is electricity? Electricity is basically movement of electrons from the negative terminal to the positive terminal. Is that okay with everybody?
Yes, sir.
All right. So if we have a battery in a particular inner circuit, the battery has a negative point and a positive point. The negative point has excess of electrons and the positive point has less electrons. So the electrons try to move from more electrons to the less electrons to the positive side because it is attracted to the positive side. So that movement that is caused is basically the movement of electricity. Okay, so that is movement of electrons. Okay, but the electrons move from the negative terminal to the positive terminal, but the conventional electricity moves from positive to the negative. So I will keep on emphasizing on this again and again. All right. So what is a capacitor? Capacitor is basically a kind of um,
Sir, you are not audible properly.
am I not audible? Everybody, am I not audible?
Sir, you are.
Yes, I am audible.
You audible. There was some disturbance.
Okay, okay.
Now it's
All right. So anyway, so a capacitor is kind of an element which is basically kind of a thing with two plates, and the two plates are separated by an insulation. And when you supply electricity, you can see the cursor. There is a positive terminal of this particular of this capacitor, and there is a negative terminal of this particular capacitor. So when you supply a charge to this capacitor gets charged, and when you remove the electricity, it gets discharged. That means it keeps on being charged for some time, then it keeps on discharging for some time. So that means ऐसा नहीं है कि the moment I remove electricity from something, it is automatically discharged instantaneously. But the capacitors keep the charge for a particular period of time. Okay. So capacitors, why are they used? They are used in circuits where we need electricity to be retained for a particular period of time. All right. So let me just, okay. Capacitors. What are we using a capacitor for? We use a capacitor for um, uh, because it remains charged for some time. I need a particular component to remain charged for a particular time. I'll use the capacitor for it. Although we can use an inductance also for it. So we'll do the inductance later on. Capacitors allows AC to pass through, not DC. So it prevents DC from passing through a capacitor, but it allows AC to pass through a capacitor. Okay. So anyway, we'll do capacitors when we do capacitors. Okay, we'll use capacitors in our circuits also, in our Tinkercad also. Anything else before I actually start off with my
After
Excuse
the
me, sir.
breadboard.
once again?
Excuse me, sir.
Shweta? Yes,
So
beta.
can you please explain the logic behind? Can you please explain the logic behind that assignment, like that you gave?
Logic behind the assignment. Yes, the 555 timer wala.
Yes, sir.
Okay, you all have done this, right?
Yes, sir.
Okay, most of you
Yes,
have
Yes,
done.
sir.
How
sir.
many of you have done this?
Yes, sir.
Okay, 555 basically is a timer IC. Okay, a timer IC basically is used to do anything which requires synchronization. For example, to create a clock, to put something switching on or off, something like this. So when anything that requires a timing kind of a thing, basically uh, would require this IC. And this IC has various terminals, has 8 terminals. You can see the terminal 1 is starting from here. So 1, 2, 3, 4 on this side and 5, 6, 7, 8 on this side. Uh, I will not go into too much of details here, but there are some things in this IC which are fixed. For example, terminal number 8, pin number 8 of the IC is always gets the positive charge. So you can see that this is point pin number 1 and it is getting positive charge from the battery which is coming from here. Okay. You can see that this is positive, negative. These two rails, the upper rail and the lower rails, all are positive and negatively charged properly. The outer ones are positive, the inner ones are negative. You can see that. The IC, in the IC, pin number 1 is always ground and it is grounded. If you can see, pin number 14 is grounded to, to the negative. There are things which are always there almost 90% of the time. Pin number 2 and pin number 6 are connected. One is called as a threshold, the second is called as trigger. So trigger and threshold, they are connected together. You can see they are connected using this green wire. Okay, rest all are support circuitry, which are basically giving some voltage to the IC or some timing to the IC. You can see there is a big capacitor over here. This is the electrolytic capacitor. This is basically giving the charge to this to the IC, and changing the capacitance of this particular capacitor will basically change the timing of this switching on this LED. Okay, so normally if I have a 100 microfarad capacitor, this black one, it will have a different kind of a timing switching on and off of this LED. Whereas if I have 1,000 microfarad, it will have a different timing. Okay, we will not do much in details here. I just wanted to know whether you can actually connect everything properly. So 90% of you could connect everything properly. You could connect everything properly. So and 90% of them were actually working. Those LEDs were actually blinking. So I'm very happy for that. Uh, अथर इससे ज़्यादा we will not do this. Okay, so we'll go on to our.
Thank you, sir.
Let's start with Tinkercad. सबसे पहले we'll work on the breadboard, and let's see the breadboard in full. Now, this is the breadboard, and you have seen this breadboard last time also. Now, this is a revision class, so naturally we
Excuse
will.
me, sir.
Yes, beta.
Sir, the class 10 students, especially me, I'm not able to understand that. The last class I attended was you were telling about electricity and just the basic how Tinkercad works. So after that, we have missed all the classes. So I'm not able
Yes.
to connect with the things.
Don't worry. Whatever you have missed, we will be doing now. Okay. Then in the next class, in the previous class, I had actually shown them physical components like resistances and ICs and the breadboard and everything, and I explained
Yes, sir.
this in the previous class. So whatever we did in the previous class, we will be doing here, and
Okay,
I
sir.
will be explaining. For example, somebody asked about capacitor. Yes, I'll be telling you about capacitor here when I connect it to the breadboard. So you will know everything. So don't worry about it.
Yes, sir.
Okay. All right. So this breadboard, you can see when you bring the cursor to any one of these sockets, you can see that everything lights up. So that means if you connect all these green ones are actually connected to each other. So that means if I connect anything from anything here is actually connected all the way to the other side also. Okay, so that means these 2 points are actually connected in internally over here. Okay, so these are all connected, these are all connected. Similarly, these are all connected. We normally put a positive charge here, and these are all connected. We normally put a negative charge here. Okay, so that means if I have a battery, let me have a smaller battery here. So if I have a battery and I connect the positive charge here and the negative charge here, let me straighten this up a little bit. All right, and let me have this as red in red and this in black. Please remember, many of you created the assignment yesterday but did not color the wires properly. They should be colored properly. Okay. Okay, now you can see that I have connected the negative to this point, this side of the rail. Now these are all connected, so that means everything here is connected to the negative of the battery. And these are all connected to the positive of the battery. Let us connect the lower rail also. So we can connect from here going on to the negative, and from here going on to the positive. Let me color this as red. So that's done. So now we can see that I had connected negative to this point. All these are connected to the negative. ये उल्टा हो गया. This is black. The lower one is red. Now it's fine. Oh, हमारा ये भी उल्टा हो गया. So that means this should have been connected here, and this should have been connected here. Yes. Okay. All right. Are we okay? So that means, can you see that this particular point, this point that I'm talking about here, is now positive charged because this is connected to the entire rail. This is connected to the outer rail from this side, and this is connected to the positive of the battery. So you can see that this particular entire row and this entire row, they are both positively charged, and this entire row and this entire row, they are all negatively charged. Are we okay so far? Yes?
Yes, sir.
Okay.
Yes, sir.
Now, these are outer rails. These are basically for giving the electricity to the breadboard. So the breadboard electricity comes from these two rails or these two rails. These rails, these inside ones, these are basically used for placing components. And here the structure is a little different. Here, 5 of these are connected at every point of time. For example, these 5 are connected, and these 5 are connected. These 5 are connected. So that means, now please remember line number 27, this is a separate group and this is a separate group. So if I have anything connected here, there will be no connection there. All right. Let me just ask you, what is going to happen if I do this? If I do this and if I do this, what what is connected? What is line number, wherever I'm pointing at the moment? Is it a negative charge or a positive charge?
Sir, positive charge.
How? I'm talking about J23, okay? Now see the connectivity now. This is connected to the negative. It is the red colored wire, no problem. But this is connected to the negative. So negative is connected here. These are all connected. I have not connected anything here, by the way. Have I connected? Did I connect anything here?
No, sir. No, sir.
No, I did not connect. Okay, sorry. I did not connect anything here. So there's no connection there. So I'll have to have this and I'll have to have this. Now tell me, this 22 is connected to what?
Sir, negative.
नेगेटिव ओके सो अगर ये वाला पॉइंट हम देखें तो ये वाला पॉइंट कैसे कनेक्टेड है आप देखो ये इसके साथ कनेक्टेड है तो नेगेटिव है ये इसके साथ कनेक्टेड है तो ये सारे के सारे नेगेटिव हैं ये इसके साथ कनेक्टेड है तो ये सारे के सारे नेगेटिव हैं ये इसके साथ कनेक्टेड है तो ये भी सारे के सारे नेगेटिव हैं ओके ऑलराइट लेट्स नॉट गो सो फार let me now connect a resistance so I'll put a resistance here. So if I connect this to this, can I say that the negative that I have connected the one part of the resistance to the negative?
Yes.
Yes.
Sir.
If we connect if I connect the LED now and LED का ये negative इसको हम reverse कर देते हैं. So cathode should be negative, right? So it is connected to the negative. Okay. अभी पूरा connected है ना negative से. For example, from here this is negative. So this whole wire is negative. This is going through the resistance, but still it is negative. And my cathode is connected to the negative. Is it okay or not?
Yes, sir.
Cathode is supposed to be connected to the negative, right? Okay. And anode is supposed to be connected to the positive. So how do I connect it to the positive? I can connect it from here and going on to the positive. Okay, let us make this red. ये डायरेक्ट ही कर दिया मैंने. Are we okay so far? So what I have done is
Yes, sir.
Yes, sir.
yeah. So I've connected the resistance in series with the resistance, the LED in series with the resistance. On the positive side of this is direct connection to the battery, and on the negative side of the LED is connected through a resistance to the battery. It is goes all the way around this now. If I start the simulation, the battery goes up. Yes. So let me decrease the resistance here. Let me make it 500 ohm, which is half a kilo ohm. And I'll start the simulation. It goes a little more brighter. चलो ज़्यादा bright नहीं हो रहा. अच्छा, ये बेचारा सेल ही हमारा 1.5 volts का है. So shall we increase the number of batteries here? Number of batteries is 3, and you can see that it is going काफी bright now. Yes. Okay.
Yes, sir.
See now it is very bright now. Okay. All right. Um, all right. So this is the breadboard. So you can see that the breadboard is connected in. Um, I had given you some assignments to do. Let us do those assignments here. For example, if let me remove everything from here. And
Excuse me, sir.
yes, beta.
Sir, I wanted to ask about this breadboard. Sir,
Okay.
you connected one red wire diagonally in the block below this LED. So what was that for?
This was to connect. See, just a second. This was to connect the positive side of the battery to the positive. See, when this LED is connected to this point, right? This point,
Yes, sir.
and this point is connected through this entire rail. Here, this one, smaller fiber.
Okay.
So I can actually, I could have connected it
Sir, but
from here.
this is yes, sir.
Okay, I could have connected directly from here, and this would have gone to the positive side. So the battery is connected to the positive side of the LED directly, and to the negative side of the LED through this whole paraphernalia, through the resistance, and then to the negative. Okay.
Yes, sir.
Okay, just a second. All right, you will understand this now. Main thing to understand is that these five are connected. These five are connected. Okay. If you remember, we had done some resistance in series and resistance in parallel kind of a thing when we actually did. All right. Suppose I connect the resistance like this. What do you think is going to happen?
Sir, short.
It is basically
Hmm,
shorted. Both the
nothing
terminals
like
are actually connected to the same
yes,
rail.
sir.
So we can say that
Yes, sir.
both the terminals of the resistance, they are actually connected together. So it is of no use at all. Okay? It is of no use at all. So that means if I connect it through like this, and then I connect my LED like this, and okay, and I connect it like this, what is going to happen?
Sir, it will go.
Sir, it will glow. It
Sir,
will
it will
glow.
not work.
It will not work.
It will
What will it
not
not
work.
work?
Sir, it will short.
It will short
Sir, because the resistor is.
because the resistance is shorted, right? It is as if these two are connected. बीच में resistance तो है ही नहीं समझ लो, right? ठीक है ना? तो it is something like we have connected the resistance like this. अगर हम ऐसे connect कर देते हैं तो क्या होगा? The current is actually going to go through
Sir,
this
it
wire to
will
the
work.
LED directly, right? ठीक है ना? The current is going to go through this wire directly to the LED, right? Resistance के through तो जा ही नहीं रहा वो. Resistance तो बेकार हो गया ना? So that is why
Yes, sir.
when we connect these resistances, we connect them like this. Okay. All right. Uh, okay. Now, if I connect it now, what is going to happen? Why is it not switching on?
Sir,
Yes.
So the sides are not like the sides
Sir,
are
it should
wrong.
be flipped. The LED.
The LED,
So
what about
the
LED?
cathode and anode are not in correct.
The cathode and anode are not properly aligned. They are actually double down. So this is the anode, which is the positive side, is connected to the through the negative. So we need to reverse that. We can do it reversing from here. It is now reversed. And let me just bring this to this side. And when I connect it now, it will on. It will switch on. Right? Okay. And if I connect this
Yes, sir.
here and start the simulation, it will
Yes.
actually start. Okay. You saw that? Yes. All right. Let's do some experimentation now. Okay. Let us have a few resistances in series. So shall we have resistances in series? So we'll take another resistance and align it like this, and take another resistance. If I've aligned one of the resistances, I can just say Control C and Control V and get another one. So I don't need to align it again. Can you see that all these are now in series? एक काम करते हैं, इसको हटा देते हैं. Okay, are these in series? Yes or no? They are not connected to the current at the moment, but are they in series? In series means,
Yes, sir.
Yes, sir.
series actually
Yes,
means
sir.
one end of the terminal is connected to the another end of the other terminal. So that means the terminals are not connected together. Let me put a few of these in parallel over here now and see how things happen. If I put it like this and I put it like this and I put it like this, are these in series or parallel?
Parallel.
These are parallel. Why? Because all of these
Parallel.
terminals are connected. All of these terminals are connected. So when they are connected, these are called as parallel. But when one end of this is connected to the other, उसका दूसरा किसी और के साथ connected है, we call this as series. Okay, it doesn't matter whether the components are the same. For example, when we connected the LED with the resistance, they were also in series. Alright, so I could have connected, for example, I okay, I'll just copy again. If I have this and the LED and connect this to this, can I say that the LED and the resistance are in parallel? Yes or no? For a second.
Yes, sir.
They are in parallel. Wait a second. Somebody is trying to just a second. Somebody is late. Okay. So these are in parallel. Why? Because these are connected. These are connected on one side, and these two are connected on the other side. Parallel.
Excuse me, sir.
Yes, beta. But when it is this kind of a situation,
Sir, at 5 o'clock, sir, can I leave? I have my taekwondo.
once again, once again,
Excuse me, sir.
yes.
Sir, can I leave at 5 o'clock as there is my taekwondo class?
You can leave at 5 o'clock. This is being recorded, so you'll get the recording. Okay. So you
Yes,
understand
sir.
what series? Yes, you can leave whenever you wish to leave. So now
Okay.
you can see that these terminals are in series and these are in parallel. So let us see now how do we connect them. Let's connect them now. On this side we connect the positive and on this side we connect the negative. Let us connect it here so that you can see the breadboard in working. And this is positive. Now you can see these three particular these three resistances are in series, right? Okay. What would be the total resistance of
Yes.
these three? If this is 1 kilo ohm resistance, so 1 kilo ohm plus 1 kilo ohm plus 1 kilo ohm,
3
this
kilo
would
ohm.
be
3 kilo
3
ohm.
kilo ohm. Okay. So what did we talk about voltage? What happens to voltage when you have this thing in series? Then what happens to voltage?
Voltage is divided.
Voltage is divided. So what we'll do is we'll just have a multimeter. We'll bring a multimeter here and we'll connect the multimeter to the positive, to the negative side and to the positive side and see what voltage does. And it is actually giving the voltage at the moment. Okay. All right. So when I start the simulation, it says 4.5 volts because actually my battery is 4.5 volts, right? Yes or no?
Yes, sir.
Yes.
Yes, sir.
Now, if I connect this part to one of these resistances, now it is this voltage now being checked by the multimeter is actually across this particular resistance, and we know for sure that the resistance, the sorry, because of this resistance in series, the voltage is now divided now. How is it going to be divided if I act? Okay, how is it going to be divided? This is going to be 1/3 of the voltage. Okay, काम करते हैं इसका कलर चेंज कर देते हैं so that ये हमें पता चलता है नेगेटिव है. Now if I start the simulation, what is the voltage going to show here now?
1.1.
0.5 volts. Yes.
Yes.
Okay. What happens if I change this to this and change this to this? What is the voltage now?
1.
1.5 volts again, because this is again it is divided, no? So every resistance is going to, across every resistance the voltage is going to be 1/3. So 1/3 is 4.5 is actually 1.5. Now if I do it across two resistances, what is it going to be now?
3 volts.
It's going to be 3 volts. If I move it even further, how much it is going to be now?
4.5.
4.5 volts. Now you have understood now what this division of voltages actually mean. Are we clear? All right. So the voltage is divided when it actually goes across the when the resistances are actually in series. Are we okay so far? Class 10 students, you would be understanding this much more.
Yes, sir.
Yes. Okay, good. Okay, what do we do now? Okay, when we actually, okay, now let me tell you how to check uh, current. When we check voltages, the voltages are checked uh, with the multimeter in parallel with the system. See, when I want to actually check across this particular, sorry, simulation was on. When the simulation is going on, you cannot change, okay? So now see what is happening here. The multimeter is in parallel with this resistance, right?
Yes.
Yes. So the multimeter is in parallel with the resistance. So whenever we are checking voltages, the multimeter should be in parallel with the component जिसके across हमने voltage check करनी है. Are we clear? All right.
Yes, sir.
Okay. But when we talk about current, the current should be through, should be in series. Now, how do we make it in series now? So let us remove these wires and put this in series. करंट चेक करने के लिए हम इसको थोड़ा सा इधर ले जाते हैं, इसको थोड़ा सा इधर ले जाते हैं, so that there is a gap here now. In this gap, I can put the, now can you see that these two resistors are not connected to each other? There is a gap here.
Yes.
Yes,
And
sir.
yes, so what we'll do is we'll connect the multimeter across this gap now and change this to amperage, and now check the current. See, it is showing you the current which is 1.5 milliamps. Okay, so 1.5 milliamps, right? So if the resistances are in series, the voltage is divided, but is the current divided?
No, sir.
No,
No, sir.
the current is the same. The current remains the same. Okay. What happens when we actually have it in parallel? Then what is the rule then? What is
Sir, it is
divided?
vice versa.
It is the reverse now. The current is divided. The voltage
Um,
remains the same. Yes, the current
Yes,
is
sir.
divided, but the voltage remains the same, right? Okay. So we will not do that experiment here. We'll not do that experiment here. Okay. All right. Uh, okay. Now, what else do we do today? Potentiometer, yes. Potentiometer. Potentiometer is the first thing that we need to actually work on. Let us have a breadboard here. Let us have a potentiometer here. What is a potentiometer? I had given you assignment, उसके अंदर भी potentiometer use कर रहे थे, I think. Yes.
Yes, sir.
ठीक है.
Yes, sir.
So what is a potentiometer? And how different is it from a resistance?
Sir, in the potentiometer, we can adjust the resistance by moving the slider.
Okay, by moving the slider, we can adjust the resistance, whereas in this particular kind of a resistance, this resistance is fixed. If it is 1 kilo ohm, it remains 1 kilo ohm. Okay, इसके examples हम वैसे बहुत बार देख चुके हैं. The dials of our AC, of dials of our CD players and fans and everything. These are all basically potentiometers. So how do we use a potentiometer? A potentiometer, if you can see the potentiometer here, I'll enlarge this now. See, it has three terminals. One is terminal 1, one is terminal 2, and one is the wiper. Okay. If you see the actual potentiometers,
As you, sir.
Anji beta,
Sir, what is the wiper?
wiper, I'll tell you. Too. If you see the
Okay.
actual potentiometer, sorry. If you see the actual potentiometers, this is an actual potentiometer. This also has three terminals, and three terminals. The two are terminals and one is the wiper. I'll tell you what wiper is. Just give me a minute. Okay. And you can see that these people also have termed it as VCC. and ground and output. So that means one particular end is connected to the positive of the battery, one is connected to the negative of the battery, and this actually gives you the output. This is the variable resistance that we are talking about here. Okay. Okay, so that means everywhere you see, it doesn't matter what kind of potentiometer it is, it will always have three terminals. All of them will have three terminals. Let's come back to our own potentiometer. What happens now? See, the potentiometer is showing as 250 kilo ohms. That means the resistance between terminal 1 and going on to terminal 2 is actually 250 ohms. Alright. So when I'm connected, when my wiper is connected, I'll start my simulation, nothing is going to happen, but my wiper will work. So if my wiper is here, there is, and this is the positive, there is no resistance. And if I bring it here, this is half the resistance. That means अब देखो अब center में है यहाँ पर. If the total resistance of the potentiometer was 250 ohms, what do you think is the resistance between terminal 1 and the wiper?
Sir, 125
125 ohms.
ohms.
Okay, 125 ohms. Let's make this as 1000 ohms. So if I make it 1000 ohms, and if I bring it somewhere middle, it is 500k, 500 ohms here. Okay, and if I bring it here, it is 750 ohms here. If I bring it here, it is 1000 ohms now. Is it okay?
Yes, sir.
Okay. So the wiper is basically is the center point, which is basically the containing the varying uh, voltage. Okay, and current, of course. Okay, let us try to use this. How should we use it? Let's not have the breadboard. Let's not have all this wala here. I'll have a battery. This battery is also a huge battery. Let's connect the positive side of this to this terminal and negative side to this terminal. And let's have this as black and have this as red. Okay. Now I want an LED to be connected. Okay, let's have an LED to be connected. Let's can have LED. This is the anode positive, cathode connected to the cathode black, okay, and this connected to the wiper. Let's have this as a separate color, maybe green. So what is going to happen now? If I'm in this particular situation, let's have this as say 250k only. Okay, if it is in this position, there is the current goes from here to the wiper, and out from here. Is there any resistance? No resistance at all, right? And it goes out to the LED. No problem. So if I start here, there is no resistance, and the LED is very brightly lit. What happens when I increase this? See, the light, the LED has gone out now. फर्क पड़ रहा है ना?
Yes, sir.
See what is happening here now. आपने देखा कनेक्शन कैसे किया हुआ है मैंने? पहली तो बात है, एक काम करते हैं, इस कनेक्शन को हटा देते हैं और इस कनेक्शन को डायरेक्टली अर्थ कर देते हैं. You probably did not use the third terminal, right? I think so. You did not use the
Yes,
third
sir.
terminal.
Yes, sir. Yes, sir.
Let us
Also, we
try to use it without the third terminal and with the third terminal. Okay. Now see what is going to happen now. See what is happening now is when it is the wiper is in this position, there is no resistance, and when the wiper is in this condition, there is most resistance. but the LED is still lit up. LED अभी भी जल रही है, क्यों भला? क्योंकि उसको 250 किलो ohms का रेजिस्टेंस मिल गया, 200 किलो ohms. Let's make it 100 किलो ohms and let's see. अगर मैं यहाँ पर देखूं, अभी भी लाइट अप हुआ है. ऐसा क्यों है? आप देख रहे हो अभी फर्क क्या पड़ा? I am using I am using this one only as a resistance now. I'm only using the potentiometer as a resistance. So see what is happening now. The current goes from here. How much of resistance is it getting? Is the LED getting?
100.
100K.
100 kilo ohms. Okay, 100 kilo ohms. ठीक है. अब क्या हुआ? और अब कितना है?
0.
So that means आप देखो, this is only working to change the resistance now. The potentiometer is working to change the resistance. You need to understand this, okay? Because you will be using the potentiometer at so many places. See what is going to happen if I connect the third terminal of this thing also. Let's make it black. I've connected the third terminal also. Now see what is going to happen. Tell me what is, if the wiper is in this position, no resistance, it is turned bright. But if I bring it to the right hand side, it goes off. क्या हुआ? अब देखो, मैंने इसको नेगेटिव पे कनेक्ट कर दिया ना, तो अगर मैंने वाइपर को नेगेटिव पे कनेक्ट कर दिया, तो डोंट यू थिंक द करंट इज गोइंग फ्रॉम, अगर देखा जाए एलईडी का सर्किटरी में, इट इज गेटिंग 0 वोल्टेज एट द मोमेंट.
Yes, sir.
ठीक है, इट इज गेटिंग 0 वोल्टेज. सो अगर मैं इसको हटा देता हूं यहां से और फिर सिमुलेशन करता हूं, तो अभी 0 वोल्टेज पे कभी नहीं जाता वो. It will always have some voltage. Why? Because this is working only for as a resistance, that's all. But if I connect this to the negative, the third next terminal also, what is going to happen is, when it is in this position, it is actually, this point is actually connected to the earth. So देखा जाए तो LED के दोनों points earth negative से connected हैं. Can you see?
Yes, sir.
Yes. So this particular cathode is connected directly to the negative, whereas this is connected through the potentiometer to the negative. Yes.
Yes.
Yes. So when I take it to this side, what is happening now? One side of the LED is connected to the negative, but the other side is connected through the wiper to the positive, and it is getting full voltage. Okay. So why would you want the 3 terminals to be used?
Sir,
When
because
you
when
want,
we will
when you
change the
want, once again,
sir, because when we use fans usually, then we won't have the option to just put it off. We need another switch.
yes, okay. In fact, when you have a fan wala regulator also, it actually goes to 0, right? It goes to 0. So this is why if all the 3 terminals are used, it actually goes to 0. In fact, ये उल्टा ही लगा हुआ है हमारा, जो ये रिवर्स में होना चाहिए था, पॉजिटिव उस साइड होना चाहिए था, so that. But anyway, you can see here it is full and here it is 0. So when you want 0 to full, you will use all the 3 terminals. When you want 0 to full voltage. But if you don't want 0 to full voltage, then what do? Then you remove one of them. It actually will have some voltage left. Okay, I think I am recording this so you can go through my video again and again, and you can just play this around, play with this. Okay, are we fine?
Yes, sir.
Yes, sir.
Okay, I will send you links to all these so that you can also play around with these. What do we do next? Uh, Capacitors. We use a capacitor. Okay, let us use a capacitor. Let us see the working of a capacitor. I told you will see the working of the capacitor. Let's have the electrolytic one. Polarized capacitor. Okay. Then uh, let's have a switch. Yes, switch may. Were we all okay with what the switch does? This one. Were we okay with what this switch does? This also has two terminals and
Yes, sir.
one in the common. So that means the switch, if it is on this side, these two are connected. And if the switch is on this side, these two are connected. Yes? Any problem?
No.
No.
No, sir.
Then I need an LED. Then I need, sorry, resistance. I need an LED also. Okay. Let's do the connection now. I want to place the resistance, the capacitor in such a way that it is sometimes with the flick of the switch, this is charged. So let's connect this. Uh, this is negative. Let's connect the negative, make it black. Let's connect it through the switch. Let's make it red. And going on to the capacitor. Uh, if I have this part only, and if I start the simulation, and if I say now, if I switch this off, what is going to happen? What is going to happen? Is this battery and the capacitor are they connected?
No, sir.
No. If I connect it like this, the capacitor is being charged, and if I disconnect it, if I switch this off, this capacitor is not being charged. Okay, अब चार्ज नहीं हो रहा, राइट? डायरेक्टली कनेक्टेड तो है नहीं बैटरी के साथ. तो एक काम करते हैं, let's not have this, but let's have, इसको भी हटा देते हैं छोटा सा. Let's have the multimeter and see how the multimeter shows now. Let's have the multimeter, and let's have the multimeter connected to the positive side of the capacitor, to the positive side of the capacitor, and the negative side of the capacitor. Let's make this black. Is it making sense, guys? So what happens is now when the switch is on to left through the left side, the capacitor is being charged. This will also show a voltage, but when I switch it off, this will keep on showing voltage. Let us see that now. ये बेचारा पिछली बारी से ने चार्ज तो किया नहीं उसको. Are they connected? So when I connect it now, it is showing 9 volts. Yes, it is showing 9 volts. Why? Because the current is going from the battery to the capacitor. On both sides they are connected, so no problem. The capacitor is being charged. Yes. But when I switch it off, you can see the capacitor. What happens to the capacitor now?
Sir, your screen is freezed.
Is it?
No, sir. Sir, the voltage is reducing like
Voltage
every
is
minute,
reducing.
every
So
second.
yes, Mridul, maybe something wrong at your end. Okay, can you all see that the voltage is decreasing now?
Yes, sir.
Yes,
Yes.
sir.
Why? Because I have now disconnected the battery, and the battery is not connected to the capacitor anymore. But the multimeter is still showing voltage. Why? Because the capacitor was charged and it is now slowly discharging. It has come to 5 volts, 5.8 volts now. If I switch it on, it becomes 9 volts again. If I switch it off, it becomes whatever. Okay? Alright?
Yes, sir.
Mridul, are you okay with this? Can you see the screen?
Yes, sir. Earlier also, sir, I wasn't the one to point out. I was able to see the screen.
Let me remove this particular thing and let us have resistance along with basically रहने देते हैं and LED. So इसको we'll connect it to one side. This is the anode positive. Let me connect this to the positive, and this is red, and this to the negative, and this is. Uh, does this structure make sense to you?
Yes, sir.
What is
Sir,
going to happen when I switch this on? The capacitor is going to be charged, and the LED is also going to light up because they are connected in parallel, both of them. The capacitor as well as this structure, they are connected in parallel to each other. But when I switch it off, the battery is going to be disconnected, but the capacitor, because it is charged, the LED will remain on for some time. So let us see now. There is nothing at the moment because I have switched off the thing. Let me switch it on. The LED switch is on. But when I switch it off, वो धीरे धीरे बंद हुआ है. ओके, एक काम करते हैं, इसका रेजिस्टेंस थोड़ा सा और कम कर देते हैं. 500 ohm resistance कर लेते हैं, half a kilo ohm. So when I connect this, when I switch it on, now when I switch it off, अब ऑफ हो रहा है. ठीक है, फिर से करके देखते हैं. लेट अस मेक इट फुल स्क्रीन. Switch it on. When I switch it off, अब ऑफ हुआ है. ठीक है, did you see that, everybody?
Yes, sir.
Okay, so when I switch it on, अभी on हो गया. But when I switch it off, battery is disconnected और ये अब जाके ऑफ हुआ है. ठीक है, ओके, एक काम करते हैं. अगर हमें इतना ही हो रहा है तो हम एक ये भी कनेक्ट कर देते हैं साथ में, हमें वोल्टेज भी पता चलती रहेगी. और तो we'll connect this to the negative, this to the positive. Where is it? Okay, and this is red. Always make sure your the wires are proper. Okay, so when I connect this, when I start the simulation, अभी तो बेचारा millivolts में दिखा रहा है. That means it is not. So it is showing 8.98 volt. Why is it showing 8.98 volt? Why not 9 volts?
So because some energy is dissipated.
Yes, because some energy is dissipated to the LED and stuff. So because of that, there is a voltage drop there. Okay. So when I switch it off now, see what is going to happen now. See वो एकदम से डिसिपेट हो गया. See 8.98 वोल्ट से सीधे ही 1.31 and it is gone now. एलईडी भी बंद हो गया बेचारा. एलईडी को भी एटलीस्ट 3 वोल्ट तक चाहिए होता है, उससे उसके बाद वो भी बंद हो जाता है. अभी ओके. Let's change this to 1000 microfarads. Okay, let's see now. इनफैक्ट इससे फर्क नहीं पड़ेगा, ये एक्चुअल में फर्क पड़ता है. Actual capacitor, if you increase the capacitance, it will store more charge for a longer period of time. ठीक है. Oh, okay. Are we okay so far?
Yes, sir.
Okay. एक काम करते हैं. Let me now. We'll finish by around 15 minutes. ठीक है बच्चों. एक काम करते हैं, मैं एक Arduino board दिखा देता हूँ, because tomorrow we are actually going to start with the Arduino board and the programming of the Arduino board. This is my Arduino board. Actual Arduino boards. So can you see the screen, all of you?
Yes, sir.
Yes, sir.
Yes.
This is the
Yes,
actual
sir.
Arduino board, and इस Arduino board में अगर तुम देखो, let us see that only. ये वाली better है. यहाँ पर अगर आप देखो तो these are the pins where you can connect your wires to. Okay, cables यहाँ पे connect कर सकते हैं. This is the chip, which is basically a microprocessor. So it is as good as in fact, a computer here, a small computer, because this Arduino board can store a program and run the program. See, a computer can do many things. You can write a program, you can develop a program, you can compile a program and run the program. But this Arduino board can only run a program, that's all. ये store करके run कर सकता है बस. तो कहाँ run store करेगा? It will store it into this chip and it will execute it. And it will execute it, and it will, whatever is the output of that will happen in those pins. Now let us understand what these are. Now we'll start off this pin now. This pin is actually a 3.3 volt pin and 5 volt pin. All right. The voltage coming into the Arduino can come from this particular point. This is connection to the PC actually. Connection to the Okay, Mridul, you were disconnected for some time, right? Okay, so this is the power which is coming from the PC. You can also give the power from using a battery or something. That is this point. Can you see the point? My mouse cursor?
Yes,
Yes.
sir.
Yes. Okay. And if you want to take the third point where we can give a voltage to this Arduino is from here. This is called as a V in. V in actually means voltage in. So voltage given to the Arduino. So voltage to the Arduino can come from the computer, from the battery, or using this particular pin, right?
Yes, sir.
Okay. Now the voltage coming out of the Arduino, if I want to connect something to the Arduino which requires voltage, so if I want a 3.3 volt, I will connect here. If I want to connect 5.5 volts, I'll connect here. These are the negative points. Negative points means the minus points, the battery ka minus point. So if I want to connect an LED, so how will I connect an LED? I'll connect an LED with the anode positive to the 5 volt here and the cathode to the ground here. This should work, right? So this is my positive, and this is my negative. If I start the simulation, it is going to give me some voltage, yes, and the LED blows. All right. Let me give it a smaller voltage. Let me give it a 3.3 volt. Should it work? I think it should work. It's still blue. Okay. So what do we need? We basically need resistor. Let me put a resistor here and connect one part of this to the resistor, the second part to this end. And if I start the simulation, yes, the battery is on. The LED is on. Yes, guys. ये तो एक सिंपल
Yes.
सिमुलेशन है कि मैंने आर्डुइनो से वोल्टेज ले लिया, बस वोल्टेज लिया और तो कुछ किया नहीं मैंने वैसे खास. आई एम यूजिंग द आर्डुइनो एज अ बैटरी, so I am not supposed to use an
Sir,
Arduino as a battery. Somebody asked something?
sir, you can like attach this bulb to GND and 13th pin on the digital that, and it will start to blink. So,
And it will start.
I'm blinking, sir. I just did it by like I'm just
Okay.
fiddling with it and it started.
Okay, okay, good. You experiment whatever, but I'll go according to how things go. Okay, so we have just know this part now. This part is voltage in. What does this voltage in mean? Voltage in means I want to give voltage to the Arduino. So that means if I connect a battery and I want to give a voltage to the Arduino from here. So sorry, not the negative, but the positive, and the negative to the ground. Okay, so I can give the voltage like this. If I want to give voltage to the Arduino, you can see मैंने V in से connect किया है. Are we okay? Okay.
Yes.
So you should be very clear about these pins. Ground pins are basically earth pins. This is 5 voltage out. This is 3.3 voltage out. This is voltage in. And voltage in is normally 5 volts. Are we okay so far? Yes. Okay, now we have these 6 analog pins and these 14 digital pins. So starting from 0 to 13, these are called as digital pins and these are called as analog pins. Okay, um, these analog pins, these A0, A1, 2, 3, 4, 5, 6, these are basically used to take input from the outside into the Arduino in analog form. For example, if I have a PIR resistor, yeah, PIR sensor. This is basically a sensor which senses whether there is something around or not. There is a movement around or not. Okay, so you can see now this particular sensor has 3 pins. One is a signal, one is power, one is ground. So ground you connect to the ground. Power you connect to power. Where do you connect the signal to? Signal is connected to any of
Analog.
these analog pins. Okay? So it is connected to any of these analog pins. So suppose I connect it to A0. What is going to happen now? What is going to happen now is that the PIR sensor is going to get power from the 5 volt and ground from here. ठीक है, so 5 volt ground को हम कर देते हैं black ताकि हमें clearly पता चले, and the signal is actually maybe turquoise or something. So you can see what is happening. So this is getting the ground, this is going to get power, and this is the signal. Signal is what? Signal is what the sensor is sensing. If the sensor senses something, that signal actually goes into A0 and Arduino takes input from the PIR sensor. You understand what input actually now means? Input means something going into the Arduino. And what would output mean? What would output mean?
Sir, outgoing.
coming out from the Arduino.
Yes, sir.
Coming out from the Arduino. So that means if now I want to connect an LED over here, that means if this senses something, the LED switches on. So that is the output which is going to come from here. Okay, from any of these pins. All right. Okay. Are we okay with what input actually means? The input may have been given to the digital pins also. That depends on what kind of input is coming from the device. And devices normally are analog input devices. So it will actually be taking input from the analog pins. ओके अब खास बात यहाँ पर जो हमारे हमारे डिजिटल पिंस हैं डिजिटल पिंस में 0 to 13 है यानी कि 14 है और वहां पे भी एक ग्राउंड है हमारे पास so that means how many grounds do we have here now?
Sir,
We have 3 grounds in all. And if you see the actual, sorry, this is not an Arduino. This is a power, motor. Where is my Arduino? Yeah. Oh, okay. This is the actual Arduino that we saw on that thing. उसी की फोटो मैंने ली हुई है और यहाँ पर भी आप देखो तो यहाँ पर आपको इसको ग्राउंड यहाँ पे दिखता है and you have 2 grounds here. So that means Tinkercad के ऊपर जो भी है ना सिस्टम वो exactly इसी के हिसाब से बना हुआ है. And now if you see that we have 0 to 13 pins and there are 6 pins which actually start with the tilde sign TILDE, right? These ones. So that line number, pin number 3, sorry, pin number 3, 5, 6, and 9, 10, 11. These are starting with tilde sign. So what does the tilde actually mean?
sir, it is the output for analog also. We can convert
Output
it.
for analog also. Yes, it is called as pulse width modulation, and it gives you output in the form of analog also. So that means अगर आपने analog output लेनी है तो कहाँ से लोगे? ध्यान रखो एनालॉग इनपुट जो है ये पिन जो है वो एनालॉग इन के लिए है आउट के लिए नहीं है तो एनालॉग आउट लेना होगा तो कहाँ से लोगे आप तो आप पिन नंबर 3, 5, 6, 9, 10, 11 से लोगे एंड पिन नंबर 0, 1, 2, 4, 7, 8, 12, 13 these are purely digital. They will never give you analog output. Okay. So tomorrow okay, do we have any question?
Sir, from where do we take the digital input and output then?
बेटा डिजिटल पिंस जो हैं ये डिजिटल इनपुट आउटपुट दोनों के लिए हैं एनालॉग पिंस आर ओनली फॉर इनपुट सो डिजिटल पिंस आर फॉर डिजिटल इनपुट एंड डिजिटल आउटपुट बोथ लेकिन इनमें से 3, 5, 6, 9, 10, 11 ये एनालॉग आउटपुट और इनपुट के लिए भी काम किया जा सकता कर सकते हैं ओके एनी अदर क्वेश्चन गाइस आर यू asleep all right do we have any question guys
No, sir.
Okay.
no okay
So can you please once again explain the PIR sensor?
PIR sensor I have not explained the PIR sensor Bittu. So PIR
Yes, sir. A
sensor,
little bit.
it is basically a proximity sensor that basically tells whether something is close to this particular, there is any movement in this vicinity or not. For example, if I start the simulation and you can see here, if I move this somewhere here, this red light goes right, glow कर रही है ना उसके अंदर तो जब मैं
Yes, sir.
मूवमेंट बंद कर दूंगा तो वो रेड लाइट ऑफ हो गई है दैट मींस इसका सिग्नल नहीं जा रहा बाहर की कुछ मूवमेंट हो रही है बट द मोमेंट आई मूव समथिंग इट विल ग्लो फॉर सम टाइम Okay, so this is basically called as a proximity sensor. So basically senses whether there is a movement in the vicinity. Okay,
Okay, sir. Thank you, sir.
we'll do this tomorrow, so don't worry about this. We'll do this tomorrow. We'll do start with programming tomorrow, and I will send you a PDF. You can just go through that, and I would want you to, first of all, if you have any question, then ask me a question in the WhatsApp, maybe. Okay.
Excuse me, sir.
Yes, beta.
Sir, I wanted to ask that I made that project, but it was not working, sir.
What project?
So that
Five
breadboard
five
one.
wala.
Yes, sir. IC555.
Okay, just send me the link and I'll see and
Okay, sir.
get back. ठीक है, अभी टाइम होता तो हम अभी देख लेते। एक काम करो, तुम उसको भेज दो, मुझे लिंक भेज दो व्हाट्सएप पे, एंड अभी क्लास खत्म होने के बाद हम बैठे रहेंगे थोड़ी देर। We'll work on that.
Okay, sir.
Okay, so I'm going to send you a, a PDF which contains some programming part. You just go through that, and maybe you'll understand something, maybe you will not. So whatever it is, we'll do that part tomorrow. Um, Arduino uses C++ as the programming language, which is very similar to Java. So people doing Java should have no problem. But even if you have not done anything, still there is no problem. There's not much of programming here. Okay. Do we have any question?
No, sir.
Sir,
Abhita?
sir, we will be coding this Arduino
Yes.
like in Tinkercad or another.
In Tinkercad.
Okay, sir.
Okay. In Tinkercad, over here, you can do the programming. Yeah, like over here. You don't need anything else. You can just write your program here, and the simulation will actually work on this only.
Sir, I checked this. Then there were blocks.
तो change that to text. यहाँ पे blocks है ना, blocks तो वो हमारा scratch type का program हो जाता है, which we are not very comfortable with.
Yes, sir.
If you are comfortable with it, work with it. But otherwise, normally we do text, and text basically is the C++ code वाला type.
Yes.
ठीक है?
Okay, sir.
So आप कैसे करेंगे? वहाँ पे blocks से text में change कर देंगे. ठीक है? It will
Okay, sir.
ask you something. It will ask you something like, do you want to continue? You say continue. वो टेक्स्ट में आ जाएगा या टेक्स्ट ब्लॉक से जैसे भी हो जाएगा। ठीक है। Okay guys, I think we'll call it a day. The one who asked me the question, he can stay. Rest you can. Yes, beta.
Sir, can you just tell how to connect a capacitor, polarized capacitor, to a multimeter and LED?
We had done that अभी थोड़ी देर पहले.
Sir, I didn't get that part.
You want to know this again?
Like how we will connect this the connection.
How will we connect? Okay.
Yes, sir.
Guys, as far as I'm concerned, the class is over. So whoever wishes to leave can leave, because we are not going to do anything new. We are doing only whatever you are asking. Okay. So Atharv and me are going to remain. There's another boy who asked me something. He can also stay. Anybody who wants to can stay. This was the one you're talking about.
Bye, sir.
Oh, okay, sir. Understood, sir.
This was the one.
Yes, sir.
Yeah. So
Understood, sir.
I had
Mm,
connected it this way. I'll send you this link. I'll send you all these links. You can work with these. Okay.
okay, sir. Thank you, sir.
Okay. Whoever wanted to know. हाँ जी बेटा, ये किसका क्वेश्चन था? ये किसने लिंक भेजा?
सर एकमन.
एकमन ने, ठीक है. This was one.
Yes, sir.
This is not working, right? Is this connected to? This is not connected to anything at all.
Okay, sir.
Okay. This part of the resistance is connected to terminal 3, pin 3, but not connected to anything. Let us see what it was supposed to be connected to. Okay, it is not. It is connected, right? It is connected to pin 3. Pin 3 का जो output है, that is coming through the resistance and going into. Let me change this. From here, it is going to. Okay. This also is a long wire. You could have connected it directly from here. Alright, let's see. Is this connected to power? Yes, it is connected to power. This is connected. Is the middle one is connected to pin middle one is connected to pin number 7. Yes. Pin number 2 and 6 are connected. Pin number 2 and 6 are connected. And pin number 5 is connected through the capacitor to earth. Pin number 5 is connected through the capacitor to the earth. Okay. तो ठीक लग रहा है. एंड पॉजिटिव वगैरह तो ठीक लिखा है तुमने. पॉजिटिव पॉजिटिव. Okay. From pin number 7 connected to the middle of that. Yes, connected to the middle of that. This is connected to pin number 6. This is connected to pin number 6. यहाँ पे पॉजिटिव साइड है, ये भी पॉजिटिव साइड है. Negative is connected to the negative. Negative is connected to capacitor is fine. This was a 0.01 microfarad. Hmm. getting 0 volts there. Why is it getting 0 volt?
I didn't try, sir.
Maybe I'm
Sir,
not
I think that in this the red one is negative, black one is positive.
यार यहाँ पे उल्टा नहीं कर रखा.
बट सर पिक्चर में भी ऐसे था तो मैंने फॉलो किया उसे एग्जैक्टली.
चलो पिक्चर में अच्छा नीचे वाला पॉजिटिव पे गलत लगाया हुआ है. चलो कोई बात नहीं. यहाँ पर अगर हम डायरेक्ट बैटरी को लगाते हैं तो वोल्टेज तो आना चाहिए. यहाँ कुछ शॉर्ट हो रहा है क्या? तो ये कैपेसिटर है कनेक्टेड टू अर्थ है. नंबर 4.
Excuse me, sir. I think I've got the problem.
Yeah, what is the problem?
Sir, see the red one is negative and it's entering positive down there.
हाँ दैट इज फाइन. वो ये वाली रेल की बात कर रहे हो?
Yes, sir. Sir, right side पे.
यहाँ पे
Yes, sir. It is positive and there it is negative at the bottom.
लेकिन मैंने तो वैसे ही बनाया हुआ.
मैंने भी ऐसे ही किया था सर.
तो पॉजिटिव हमने तो रेल को ही फॉलो किया है. अगर पॉजिटिव है तो पॉजिटिव यानी कि पिन नंबर 4 को पॉजिटिव मिल रहा है तो तुम्हारे वाले पिन नंबर 4 को भी पॉजिटिव ही मिल रहा है.
Yes, sir.
ठीक है. हम्म, 100 माइक्रोफैराड से कुछ होगा तो नहीं है. हम्म. Let me see mine that I had created. Where is it? And this is not the same circuit. This was a simpler circuit. चलो देखते हैं ऋतु इसमें क्या है. Okay, जरा मत्था मारना पड़ेगा.
Yes, sir. Sir, I will do one thing. I will make it again, sir.
Yeah, make it again.
I'll make it again and try.
ठीक है बेटा. From scratch बना के देख लो.
Yes, sir.
सिरे से. ठीक है.
Thank you, sir. Bye, sir.
Bye बेटा. Bye.